Hello, you magnificent mathematicians. We're going to get into these notes on making predictions. I am going to be extremely upfront with you in the fact that this is kind of on the simple side. And I know you're probably rolling your eyes like, Ms. Palmer, you say that literally all the time, but that's because it is simple. And let me explain how simple it is. So when we make predictions, we're actually looking for the words expected, or what can we expect? And usually that means that we're given either a theoretical or an experimental probability, a set of data, right? So theoretical meaning what did happen or what should happen, and then experimental would be what did happen. But as we go through the examples, you'll see what I mean. Usually we'll get experimental, but either way, we're going to set up our proportion. Favorable over total will equal however much over the new amount. And then we'll solve. Then we also need to, because some of the questions, you guys, need you to analyze each answer choice. So first we're going to go through the data. Then we'll go through each answer choice to figure out which one best fits the question being asked. It's a lot of words. It's going to be a lot of word problem type stuff. It's like those problems where every single answer choice is its own word problem, right? So just to prepare you, that's what we're going to be dealing with. But first off, let's go through a basic prediction problem. On a youth soccer team, 3 out of 12 team members have played in previous years. Based on this information, if 180 kids are in the youth soccer league, then how many could be expected to have not played the year before? So I'm going to set up my probability, right? So 3 out of 12. But this 3 out of 12 represents how many have played, right? And I'm looking for how many have not played. So if 3 out of 12 have played, then basic mental math, that tells you that 9 out of 12 have not. And the other side of my proportion is going to be x out of the new amount of 180, right? Now, we can do 2 different strategies, but first, I'm going to reduce my 9/12. Do we see how they can both be reduced by 3, right? So 9 divided by 3 is 3. 12 divided by 3 is 4. So now the 2 strategies are either to cross multiply and divide or to scale. Scaling meaning, is there an easy way to get from 4 to 180? And you know, honestly, in my head, I can't really see an easy way to do it. So I am going to cross multiply 3 times 180 and then divide by 4. So let me work this out. Sorry, we're running out of room, guys. 180 times 3. 8 times 3 is 24. 1 times 3 is 3, plus 2 is 5. 540. And I would just honestly do this on a separate sheet of paper or off to the side. So now I'm doing 4 going into 540. 4 can go into 5 one time. Remainder 1. 4 can go into 14 3 times. Remainder 2. 4 can go into 25 times. So x equals 135. Out of the 180 have not played in prior years. Okay, try that exact same logic with this problem, which is honestly the same thing. So I kind of just want you guys to practice setting up your proportion, cross multiplying, and dividing. All right, I'm really hoping that you're able to set up the proportion correctly and you were able to get 45 out of the 180 kids have played before. Cool, that's a lot of kids. 135 is a lot of kids to have never played before. But 45 did, so they're probably rock stars. Okay, let's get into the really, really wordy ones. The manager of a movie theater randomly surveyed 50 people who entered the movie theater on Friday. The manager asked about the type of movie each person preferred. The results of the survey are shown in the table. Based on the results in the table, which statement about a person who will go to this theater next Friday is true? Okay, so I see my table results. I know that the total is going to be 50. I see that action is the most. Drama is the least. I just like to analyze the table first, and actually I do that for any type of mathematical problem that gives me some sort of diagram, like a graph or a table or a T-chart or a pie chart, anything. I always analyze the diagram first, just so when I look at the answer choices, I already have an idea of what I'm looking at. And then horror and comedy are pretty close to each other, so I'm not gonna label anything in there. So now let's go through the answer choices. Answer choice A, the person is 3 times as likely to prefer comedy as horror. So looking at comedy, are they 3 times as likely to prefer comedy as horror? Meaning, is 12 times 3, does that equal 15? Nope. That's not true, right? Because 36. 12 times 30 is 36, and that is not 15. Answer choice B. The person is twice as likely to prefer drama as horror. So now looking back at here, are they twice as likely to prefer drama than horror? So is 12 times 2, does that equal 6? Now I need you to pay attention to that because this is twice as likely to prefer drama over horror. If these two numbers were switched, if horror was 6 and drama was 12, then yeah, that statement would be true. They're trying to trick you here. They are half as likely to prefer drama as horror, not twice as likely. So, nope. Looking at answer choice C, the person is less likely to prefer horror or drama than action. So now let's put together horror and drama. So horror is 12, drama is 6, and if I put those together, that's what, 18? So are they less likely to prefer horror or drama than action? And action is 17. And since 18 is not less than 17, it's greater than 17, then I know answer choice C also cannot be it. Which, yes, means answer choice D is my answer. However, clearly, we're going to go over it just to validate and justify that D is the final answer. All right, the person is more likely to prefer horror or comedy than action or drama. So I'm now going to put together horror and comedy. Horror is 12, comedy is 15. Simple mental math, 12 plus 15 is, 27. You should have been thinking it. Action is 17 and drama is 6. So let's put together 17 and 6 in your head. Should have gotten 23. All right. Is it more likely, is 27 bigger than 23, basically? More likely to prefer horror or comedy than action or drama? And yes, considering 27 is greater than 23, answer choice D is my final answer. That was so many words and so much thinking. And yes, you're going to have a lot of questions like these. So let's try another one. Steve has 2 different spinners. He spun each spinner several times and recorded the results in the tables below. Based on these results, if Steven, did I say Steve? I meant to say Steven. If Steven spins each spinner 60 times, I need to remember that. That's my new amount. Each spinner 60 times, which of the following is the best prediction of his results? So once again, I need to go through every single answer choice and figure out which one is the correct answer. So looking at spinner 1, I see red has 8, orange has 4, yellow has 2, and green has 6. If I add all of these up for spinner 1, that's 12, 13, 14, that's 20. Spinner 2 was spun a total of 10 times. So this is my, sorry, let me make a note. These are my totals, right? Because we need our totals to find our, right, because it's favorable over total. So spinner, I'm just gonna read the answer choices and then we'll analyze each one. Answer choice A, spinner 1 lands on orange 6 more times than spinner 2 lands on purple. So I need to calculate how many out of 60 orange was spun and how many out of 60 purple was spun on spinner 2. So let's set up the proportions. I'm gonna do answer choice A up here to show my work. So orange is 4 out of 20 equals X out of 60. And then for spinner 2 lands on purple, it should be 2 out of 10 equals X out of 60. All right, I'm really hoping you guys are following me here. My first proportion I set up to find out how many orange, because it was 4 out of 20, right? That's what did happen, the experimental probability. It was 4 out of 20, which is 1 out of 5, right? Because we always like to reduce when we can. So this is 1, this becomes 5. And then spinner 2, the purple experimental probability was spun twice out of 10 times, which again reduces down to 1 out of 5. Oh, that's nifty. Huh. I feel like that kind of already tells me my answer, that it can't be 6 more times because they're both spun 1 out of 5. So if I do my math, X is going to be the same regardless, right? This is where I can scale. And honestly, I probably, you know what, let me go back and not reduce. Just to show you, in this case, it's actually easier to not. Because I could do 20 times 3 and 4 times 3, so X equals 12. And then I could do 10 times 6 and 2 times 6, X equals 12. So honestly, even solving it, I still know I'm gonna get the same answer for both. So A can't be my answer because clearly orange was not spun 6 more times than purple because they were spun the same amount of times. Okay, answer choice B. Let's analyze it. Spinner 1 lands on orange 10 more times than spinner 2 lands on purple. Oh, that's cool. I'm still dealing with the same colors and I'm dealing with the same colors. So that actually makes my life a little easier because I already know that this is gonna be 4 out of 20. And this is going to be, oh, you know what? I don't even know why I'm doing this math because we've already done it once, right? It's gonna be the same answer. I mean, right? Like mathematically, if I have the same colors and the same totals, I'm gonna get the same answers. So I know orange can't be spun 10 more times. That cannot be my answer choice. I would love it for you guys to go through answer choice C and answer choice D to figure out what your right answer is. Okay, so this still equals 12 and it equals 12. So it can't be B. How nifty. Well, that problem was a heck of a lot easier than I thought it was gonna be. And honestly, you guys, this lesson is a heck of a lot easier than you guys think it is. Or, you know, if you don't think it's simple, because it keeps saying easy. It's only easy if you understand it. And I truly believe that it is a simple concept. And if you don't understand it, please, please, please don't be embarrassed. Like, truly, just ask for help, guys. That's our job. And we love to do our job. Let us help you. Let us teach you. Yeah, that's all she wrote.